Were you present in the last class or
I was present,
disconnected?
sir.
You were present. Okay. So just wait for a few minutes. Other students will be joining soon. Okay. 2 to 3 minutes. Okay, Rin. I'm going to give you a question on the previous topic that we have studied in previous class. Calculate E naught cell if E naught of Fe slash Fe plus 2 is given as plus 0.44 volt and E naught of Cu plus 2 slash Cu is given as plus 0.34 volt. Also, it is given that cell representation Fe slash Fe plus 2, which has one molarity, double slash Cu plus 2, one molarity slash C. This is the representation, and E naught of Fe slash Fe plus 2 and Cu plus 2 slash Cu is given. We need to calculate E naught cell. Can you do this?
I will try, sir.
Okay, I'm waiting.
Sir, can you explain?
See, so there is a formula for E naught cell. That is, E naught cell will be equal to E naught either cathode minus E naught anode. And one thing is important, that take E naught, that is electrode potential of a reduction potential, SRP standard reduction potential, and also at anode, since there will be oxidation and oxidation potential, but we have to take reduction potential. Also, we can write E naught cell will be equal to E right minus E left, but keep it in mind that right is for a reduction potential. We need to take reduction potential. This is right or left is for when a representation of cell is given. A representation of cell is given. Now see, you can see that this is on left hand side and this is on right hand side. That is right and this is left. Also, you know that since Fe is going in Fe plus 2, that means it is anode on left hand side, anode, and it is cathode. That means the value of Cu we need to put here, and this value of Fe, since it is on the left hand side or anode, we need to put it here. But keep it in mind that we need to keep the value of reduction potential. Now let's go. E naught cell will be equal to, on the right hand side you can see copper, and before putting the value of plus 0.34, just check it which type of E naught it is given, a reduction potential or oxidation potential. So you can see plus 2 is going into 0, that means it gains electrons. That means this value is for reduction potential. I just put minus. Now see, this is on the left hand side or anode. You can see the value is plus 0.44. Before that, you need to check 0 into going oxidizes to plus 2. That means the value is for oxidation potential, but we need to write the reduction potential. So what I told you in the previous class is that oxidation potential is minus of reduction potential. Whatever is given in positive, we have to take it in negative. We have to take it in negative because they are opposite in charges. Oxidation potential and reduction potential are numerically equal, but whenever we are going to calculate E naught cell, we need to put the value of reduction potential, not the oxidation potential. So if you are going to solve it, you will get an answer 0.3 minus minus plus and 0.44. So your answer will be 0.78 volt. Got it?
Yes, sir. Thank you.
So please write it. Madiha, this was a question that I just gave. Please write it and let me know when you are finished with
Done,
this.
sir. Done, sir.
Okay, thank you. Madiha? Madiha, am I audible to you?
Yes, sir.
Okay. Please write this question and let me know when you are finished with this. The question is same as the previous class. Then we will start the most important topic of this chapter, that is Nernst equation.
Done, sir.
Now see, Nernst equation. For a reaction, we are going to write E cell. There is a formula E cell equals to E naught cell minus 2.303 RT upon NF log to the base 10 and reactant upon product, concentration of reactant upon product. This is basically just like uh, chemical equilibrium Kc. You have studied about this in class 11. And in Kc, just suppose we write product, basically product upon reactant, not reactant upon product, product upon reactant. Also, we take product upon reactant of aqueous, not pure solid and pure liquid, because active mass of pure solid and pure liquid is 1. That's why. So this is the formula for Nernst equation, and I'm going to write everything like E cell. What is E cell? E cell is electrode potential. Electrode potential of cell at any concentration and temperature. At any concentration and temperature. E naught cell is basically a standard electrode potential. A standard electrode potential. And you know that a standard electrode potential is the concentration of a standard electrode potential is 1 m. Temperature is 298 Kelvin and pressure is 1 bar or 180. Okay. Now see, there is R, that is gas constant. That is gas constant. Then we got T, that is temperature. That is temperature. Then we get F, that is Faraday's constant, and we know the value Faraday's constant, and Faraday's constant has a value approximately after rounding of 96,500 coulomb. N is basically number of electron transferred or gained or lost. You can write number of electrons gained or lost. Okay. P is product and R is reactant. A reactant, since it is in a square bracket, so concentration of product, and this is concentration of reactant. So please write all this, then I will let you know. I will modify this formula.
Done, sir.
Very good. Nadia, you are also done with this?
Done, sir.
Very good.
Yes.
Now see, I'm just going to put the value of gas constant R, temperature. I will take it as a standard condition, that will be 298 Kelvin, and Faraday is constant, as we know that these values. That's why I'm just going to put the value of this, and we will get a formula as E is equal to E will be equal to E naught cell minus 0.059 upon N log of product upon reactant to the base 10. This is the formula, modified formula after putting the value of temperature, gas constant and Faraday's constant. We get this formula. This is very important. Now we are going to do some questions which are very important. Always remember that whenever you are going to write a reaction from a representation, just focus on what is the state of reactant and physical state, whether it is solid or liquid or aqueous. Aqueous, you can write the value, but in solid state, you don't need to write that because uh, the value of active mass in solid state will be 1. Okay.
Okay, sir.
Thank you. Let me know when you are done with this. I'm going to write a question here. The question is basically find the reduction potential. Find the reduction potential and also oxidation potential. Oxidation potential of Fe plus 2, which has concentration 0.01 m slash Fe solid at 25 degrees centigrade. It is also given that E naught cell is equal to minus 0.45 volt. Please write the question and let me know. Then I will explain how you are going to solve it.
Done, sir.
Madhya, you are also done with this?
Yes, sir.
Very good. Now see how we are going to solve it. First of all, you are going to write the form reaction for this. You know that Fe plus 2. If it is in a ionic form, that means in aqueous state, and you can see Fe is going in solid state like this. After what? After gaining 2 electrons. After gaining 2 electrons, this is in aqueous solution, 2 electrons, it will be converted into this. Now we are going to use for reduction potential or oxidation potential, we need to write the Nernst equation. E cell equals to E naught cell minus 0.059 upon N log to the base 10 of product upon reactant. Now I'm just going to put the value, nothing else, and it will be so easy. E naught cell is given as minus 0.45. You can see minus 0.45 minus 0.059. I'm just going to round it off. It will be 0.06 upon N. N is the number of electron. How many electrons it gained? 2 electrons. 2 electrons. So I just wrote 2 log to the base 10. Now see, what is the product? Product is Fe in solid state. That's why we will take 1, because active mass of pure solid and liquid, pure solid and liquid equals to 1. Okay. And what is the reactant? Reactant concentration is given as 0.01. That means 10 raised to the power minus 2. Yes or no? Let me know. Please speak up. Rim,
Yes, sir.
Madiha, and
Yes,
Sami.
sir.
Now see, minus 0.45, and you can easily cancel this. 0.03 it will be, and minus 0.03. And what we get, log and log to the base 10. And if you are going to move this from denominator to numerator, it will be 10 raised to the power plus 2. Yes or no?
Yes, sir.
Now, do you know how to calculate log? Yes or no? Do you? Does anyone know how to calculate log? Rim,
I
Madiha,
don't, sir.
Sami. Okay, see. If you have something log a into b to the base 10, it can be written as log a plus log b, and both will have like this. Now, if you have log a upon b to the base 10, this can be written as log a to the base 10 minus log b to the base 10. Now, log a to the power n to the base 10, this power will come here, and it will be n log a to the base 10. Yes or no? Got it? These are the some formulas of
Yeah, sir.
logger log, which is very important. Now see, you can see this is in power form, so I can easily write minus 0.45 minus this power will come and multiply here, and since the so it will be 0.03 into 2, that will be again 0.06, and log to the log 10 to the base 10, and whenever this and this term will be equal, this will have a value 1. Always remember, log 10 to the base 10 will have a value that is 1. So we got 1. Now see, minus 0.45 minus 0.06 into 1, that will have a value 0.06. Now you can easily add this. Yes or no? You can is 6 5 11. Wait a minute, 6 5 11, and then 4 and 5, it will be this much. Is that clear to everyone? This is electrode potential. Madiha, Rim,
Yeah, sir.
this is basically E cell. We just calculated E cell 0.51 volt, but we need to calculate oxidation potential. So I in the previous class, you know that sorry, first we are going to calculate a reduction potential. So a reduction potential in the previous class I told you will be equal to electrode potential. So reduction potential will be equal to 0.51 volt. Also, oxidation potential is negative of electrode potential, which will be also negative of reduction potential. So oxidation potential will be minus of 0.51 volt. So the answer for oxidation potential and reduction potential, you can see. Yes or no? All of
Yes.
you.
Yes,
Now
sir.
I'm going to slide it up. Please write this. Samia, are you there?
Yes, sir.
Let them write, then I will let you know what I just studied. Net dot. So, oh, this was the question. Please write it and let me know when to slide down. Again,
Sir, can you scroll down?
Yes. Done, everyone.
Done, sir.
Done, sir.
Okay. Samya, please take a screenshot of this Nernst equation. Nernst equation. This equation is called Nernst equation. And let me know when you are done with this. Samya,
Yes, sir.
did you take a screenshot of this?
1 second, sir. Yes, sir.
And this too. This is the after evaluating the value of RT and let me know.
Yes, sir. Done.
Samia, then okay. Now going to give you another question. Find the reduction potential and oxidation potential of chromium slash Cr plus 3. Cr plus 3 has a concentration 0.01 m at a 25 degree centigrade. Also, it is given that E naught Cr plus 3 slash Cr is given as 0. Minus 0.75. Please do this first. If you are not able to solve it, just let me know. Everyone done with this? Yes, I will. I'm just waiting for other students to reply.
Sir, is the answer minus 0.0295?
0.0.
2, 1.
0. Wait a minute. What happens? No, see, I'm going to explain it. All of you concentrate here. We need to calculate reduction potential and oxidation potential. So first of all, I'm going to calculate E cell. E cell has a formula, E naught cell, that is given in the question, minus 0.059 upon N. N is number of electron transferred, gained or lost, you can say product upon reactant. And how we are going to recognize whether the product or reactant is given? There is a representation from where we can easily go for reaction. Cr in solid state. See, if Cr in neutral state, that means it is in solid state and it is going in. You can see Cr plus 3. Yes or no? And this will be in aqueous state. Let me know, please. This will be the reaction or not?
Yeah, sir.
Now see, this has a concentration 10 raised to the power minus 10, minus 2. And if you are going to put the value, E cell will be equal to E naught cell, that is minus 0.75, right? Minus 0.059 upon N log to the base 10. And product, you can see product has a concentration that is minus 10 raised to the power minus 2. And the reactant, it is in solid state, that means we can take 1. Now, minus 0. Minus 0.75 and minus 0.059. What is the value of N? You can see 0 is converting into plus 3. That means 3 electrons it lost. So as I'm just going to put the value of N, that is 3, and log 10 raised to the power minus 2 to the base 10. Now you can see that this is minus 0.075, and it is basically, if I'm going to round it off, it will be 0.06 divided by 3, and you can see this is power formula. So this power will come to this, yani, that means into 2 log 10 to the base 10. Again, you can see 10, that means it will have a value 1. And again, you can cancel this 0.02, it will be cancelled by 3 into 0.02 will be equal to 0.06. So E cell will have a value that is minus 0.07. Wait a minute, I just wrote it wrong here. 0.075. Now it is 0.75. I can write minus 0.75 minus 2 into 0.02, that will be equal to 0.04. Again, this is very, you can see this will be in negative because the power is in negative. So if it is, it will be multiplied by this, so it will be positive. Yes or no? Please let me know.
Yes, sir.
Yes, sir.
So E cell will be equal to, if you are going to subtract it, what you will get? Tell me. You can solve it, no? 0.71, I think. So this is the answer. Madhya, where you had mistaken, did you realize it?
Yes, sir. I took 10 raised to minus 2 for The concentration of reactants. That's what it came.
or reactant. Since this representation you can see, we will go through that.
Yes.
We will go via this. Please write it. Done with this?
Yes, sir.
Very good.
Done, sir.
Thank you. Now let's go for next question. Now the question is basically, wait a minute. Okay. Find EMF of cell. In the previous class, we have in the previous question, we were doing only half cell reaction. Now in this question, I'll give you full cell reaction, complete cell reaction, net cell reaction. Cr converting into Cr plus 3 equals, that is given 0.1 m, double slash Fe plus 2 equals single slash Fe solid. Also, it is given that this is 0.01 m, and E naught, wait a minute, E naught cell is given as, just wait a minute, just need to put the value. Okay, no problem. Not cell. E naught Cr plus 3 slash Cr is given as minus 0.75 volt, and E naught Fe plus 2 slash Fe is given as minus 0.45 volt. We need to calculate EMF of cell. EMF of cell. Can you do this?
Sir, can you explain?
Yes. See, I'm just going to do the same thing. I'll just give you hints. First of all, just write the formula E cell. We need to calculate E cell. That will be equal to E naught cell minus 0.059 upon N log to the base 10 of product upon reactant. Now, if E naught of different process that is given, you can easily calculate E naught cell. What is E naught cell? In the previous class, we have calculated already. E naught cell is equal to E naught cathode minus E naught. Yes or no? Can't we calculate this E naught cell?
Yes, sir.
Now tell me the value E naught cell cathode. Cathode you can say on the right hand side Fe. The value of Fe that is minus 0.45 minus anode on the left hand side, that is Cr, that will be 0.75. So in naught cell you will get a value 0.03. Will it be 0.03? No, 0.3 volt. So you got the value of E naught cell. That means this is done. E naught cell 0.059. Can't you write the equation from this representation, and from that equation you will get to know what is the number of N? Are you getting my point? Please write equation for this representation, as I have already taught you how to write equations or reactions from representation. Yes or no?
Yes, sir.
Please write equation and let me know. Tell me the equation. What is the reaction? Anyone? Rim?
I'm still doing, sir.
Okay, it shouldn't take this much time for to write a reaction from a representation. Madhya, tell me the reaction. We can easily write this Cr plus Fe plus
Sir,
2
is it
will give Cr
0.26?
plus 3 plus Fe. I told you to write the equation. Oh, what you just told me. He said. So you can see it will be basically plus 2, 3 multiplied by 3. Oh, wait a minute. Just write half equation and it will be very easy. Cr is converting into going into Cr plus 3, that means 3 electrons, and Fe plus 2 is gaining 2 electron to convert it into Fe. Now multiply it by 3 and 2 and then add it. So what we will get 2 Cr plus 3 Fe plus 2, 3 to just 6 electron, and here we will get 2 Cr plus 3 and 3 Fe. This will be the required equation. Are you getting my point, everyone? Or I should explain from beginning? Tell me please, Rim, Madiha and Samia. Rim, am I audible?
Yes, sir.
Now see, basically if I'm going to write this equation, it will be 2 Cr plus 3 Fe plus 2, and there was 6 electrons will be converted into 2 Cr plus 3 plus 3 Fe, and there will be also 6 electrons. Now going to put the value. So E cell will be equal to E naught cell, which has a value 0.30 minus 0.059, and you can see n is number of electron transferred, that is 6, log to the base 10. Now see, log to the base 10 and then product. In product side, this is in aqueous solution because it is in ionic form, and this is in solid state. So we will leave this because its value is 1. So product is Cr plus 3, and whatever is its stoichiometric coefficient, it will come into its power. It will be in its power upon reactant. Reactant, you can see this is in solid state and this is in aqueous state. So Fe plus 2, and whatever is its coefficient, that is a stoichiometric coefficient, it will be in its power. Now just put the value and get your answer. 0.30 minus, I'm just going to round it off, it will be 0.06 upon 6 log to the base 10. Now tell me the value of Cr plus 3. Can anyone tell me? See the question, Cr plus 3, 0.1. So 0.1 can be written as 10 raised to the power minus 1 raised to the power 2, and Fe plus 2, 0.01, that means 10 raised to the power 2 to raised to the power 3. Again going to solve it. So it will be 0.30 minus 0.01 log. Now see, it will be 10 raised to the power minus 2, and the denominator will be 10 raised to the power minus 6. When it will go in numerator, it will be plus 6, and we will be left with 10 raised to the power 4 to the base 10. If you have any doubt in this step, let me know. Does anyone have doubt in this step?
No, sir.
Now see, 0.30, thank you, minus 0.01, minus 0.01, and apply the power formula, it will come here 4, and then it will be log 10 to the base 10, and we know that 10 to the base 10, that means the value is 1. Again it will be 0.30 minus 0.04, and you will get your answer. Just minus it.
Sir, 0.26.
0.
26.
Okay. Very good. 0.26. Madiha, do you have
Yes,
any
sir.
doubt?
No, sir.
I'm just sliding it up. Please write it and let me know. And then I'll give you another question. Everyone done with this?
Yes, sir.
Very good. Madiha, you are also done with this. Rim, Samia.
Yes, sir.
Yes, sir.
Okay. Okay. Now I'm going to give you another question. Please do it on your own. Find EMF of cell at 25 degrees centigrade, and the representation is Zn/Zn plus 2, which has a concentration 0.1 n, double slash Sn plus 2, which has a concentration 0.01 n slash Sn. It is also given that E naught Zn plus 2 slash Zn is equal to 0.76 volt, and it is also given that E naught Sn plus 2 slash Sn is equal to minus 0.14 volt. This is in negative. Please do this. Madiha, Samia, can you do it?
Yes, sir, I'm doing.
Okay. Samia, do you have any doubt in this? Please let me know the answer.
Sir, is the answer plus 0.56?
Plus 0.56. Wait a minute. Yes, it is the correct answer. Any answer from you, Madiha? Madiha, you are done with this, right? Your answer
Yes,
is
sir, I
0.
only told the
Okay.
answer.
Okay. Very good. You got the right answer. Now, we are going to start. In the previous class, I have told you that delta G is equal to minus N F T naught cell. Yes or no? And we concluded which cell will be uh, feasible and not feasible. Yes or no? Madhya, were you present in this lecture? Delta G?
Yes, sir, I was there.
Okay. Okay. Now, right topic, equilibrium constant from Nernst equilibrium constant from Nernst equation. So, as you know that at equilibrium, delta G will have zero. As I already told you, delta G when delta G less than zero, that means a spontaneous. A spontaneous, that means reaction or process will be forward, carrying forward. Delta G greater than zero, that means non-spontaneous. And non-spontaneous, that means the reaction will be backward. Okay. Now delta G equals to zero. Delta G equals to zero. And you know that delta G equals to minus NFE cell. Minus NFE cell at equilibrium. At equilibrium, it will be delta, if delta G will be zero. Wait a minute, please. This is E cell. At equilibrium, if delta G equals to zero, that means E cell will also be equals to zero. if you are going to apply this formula and putting the value of delta G, then E cell will also be 0 or not, because N is number of electron, F is Faraday's constant. So this will have some values, but E cell will be 0. Yes or no? Madiha? Madiha?
Yes, sir.
So do you have any doubt in this?
No, sir.
So please write it, and then I will explain another point in this topic.
Are you done with this?
Yes, sir. Done.
Now see, we have a formula that E cell will be equal to E naught cell minus 0.059 upon N log to the base 10, and here it is product upon reactant. Again, since E cell has a value 0, so 0 will be equal to E naught cell minus 0.059 upon N, and then log to the base 10 product upon a reactant. Now we can easily write E naught cell will be equal to 0.059 upon N log to the base 10 and product upon reactant. Now this product upon reactant we can write Kc. Kc is basically equilibrium constant, if you have remembered from previous class, chemical equilibrium. So log to the base 10 and Kc. So this is a relation in equilibrium constant, for equilibrium constant. And we can also write Kc log to the base 10, log Kc to the base 10 will be equal to E naught cell into NF. So not NF. We can write according to our requirement. Wait a minute, just remove this, then it will be more easy to understand. This has a value 2.303 RT. Just remove this. It will be very easy to understand. And at last, I will write that 2.303 RT. Again, 2.303 RT. So we can easily write NF upon 2.303 RT case, not case. So this will be, please write. Let me know when you are done with this.
Done, sir.
Now I'm going to give you another question on Nernst equation. Find the electrode potential, that can say potential at 25 degrees centigrade for an electrode in contact with a solution whose pH equals to 10, and the reaction is given as H2 slash H plus in aqueous, and it is also given that it is 180. Please do this question. Will you be able to solve it?
Sir, can you explain it?
Okay, no problem. See, so we need to calculate E cell. First of all, understand this, what we need to calculate. And the solution is present. The solution has a pH equals to 10. So with the help of pH, can you calculate concentration?
Yes.
So the concentration of H plus, since it is acidic, will be equal to 10 raised to the power minus 10 m. Yes or no? Just let me know.
Yes.
Now see, I'm going to apply the formula. E cell will be equal to E naught cell minus 0.059 upon N log to the base 10 product upon reactant. Now again, I'm going to write the equation for this. H2 will be H2 in gaseous state converted into H plus and balance it. It will be like this, yes or no?
Yes.
Now you can see the number of electron is 2 and the product is H plus and reactant is H2. Now the important thing is that E naught cell of hydrogen is 0. Basically, in next few classes we will learn about the spectrochemical series, and that series is basically has taken hydrogen as reference element, and with respect to hydrogen we calculated all the values of electrode potential. Whatever we write like Cu plus 2 slash Cu will be minus 7.0.75, that all values are calculated practically with reference to hydrogen. That's why the E naught cell of hydrogen will be 0. Just remember it for now, then you will understand in the next lectures. Okay,
sir.
0 minus
Okay, sir.
0.059 upon N. N is number of electron transferred. You know that. So how many electrons? 2 electrons. And log 10 to the base 10 product is H plus. You can see H plus, and whatever is its stoichiometric coefficient, just multiply it by it. And now H2. Whenever it will talk about gaseous state, we will take partial pressure of hydrogen. Partial pressure. Okay, are you getting my point? In constant
Yes, sir.
equilibrium constant constant, we are going to take in partial pressure, and partial pressure is given as 1 atm. Now E cell, can you calculate it now? Solve it. pH2 is given 1 atm, so which will just put 1. H plus has a concentration that is 10 raised to the power minus 10. So I think you can calculate it.
Yes, sir.
Please calculate it and let me know the answer.
Sir, when you're simplifying these concentrations, so that time it will come 10 raised to the power minus 20, right?
So wait a minute. It will be 0.06. I am just making it log to the base 10, and H plus has a value 10 raised to the power minus 10 raised to the power 2 upon 1. Okay.
Yes, sir.
Again, if you are going to solve it, 0.06 to log to the base 10, and it will be 10 raised to the power minus 1. This power will come here, and it will be minus 0.06, or you can write 0.05, because I'm just okay. 0.059 upon 2 into, you can see this is minus and this is minus. This will be cancelled, and here it will be 20 log 10 to the base 10, which has a value 1. So this will be cancelled by 10 times E cell. So now you can easily write E cell will be equal to 0.059 into 10. That will be 0.594. Yes or no?
Yes, sir.
Please write it and let me know.
Done, sir.